Okay. All right, so we're going to finish up algebra today. We stopped at the top of page 18. So we are going to finish pages 18, 19, and 20. That's our goal. And then obviously do the other packet, or at least most of it. All right, so we went through factoring on page 17, and we stopped on page 18 where we had the shortcuts with factoring, so we're going to talk about those. So you have two shortcuts up at the top of page 18. These are really helpful on your SAT. They don't really come into play so much on your ACT. But on your SAT, they will ask you for the sum of the roots of a quadratic equation and the product of the roots of a quadratic equation. So the sum of your roots is just negative b over a. Okay? The product of your roots is c over a. And this is where a, b, and c are the same as they are for your quadratic equation. Okay? So no mystery there. But let's look at how this comes into play. So SAT number 12, what is the product of all the solutions? Okay, so solutions, roots, zeros, x-intercepts, all those words mean the same thing. Solutions, zeros, roots, x-intercepts, they all mean the same thing. You all want me to write that down? Okay? All right. What is the product of all the solutions to the equation 3z squared minus 12z plus 6? All right, so product of the solutions. That's the product of the roots, same thing. So that's just c over a. So what's my c? My c is 6. What's my a? My a is 3. So this is simply 6 over 3. This is just 2. And that's your answer, and you're done. There's no need to factor this. There's no need to solve for z. It's that quick. Okay? Now, where this really shines, like this is not that hard to solve. This would not be a bad one to actually factor and find z. But where this really, really shines, where it really helps you, is when you're in that non-calculator section and they give you something disgusting. Like 2x squared plus 0.6x minus 1.2. And they tell you to find the product of the roots. It's like, what? I'm going to have to do the quadratic equation with decimals without a calculator. Excuse me? I don't think so. But they want you to know the shortcut. So product of the roots is just c over a. So c is negative 1.2. A is 2. All I have to do is negative 1.2 divided by 2. Well, this is kind of like 12 divided by 2. So 12 divided by 2 is 6. And then put the negative out front and add a decimal point. So this is just negative 0.6. Done. Okay? No need for quadratic equation. No need for anything disgusting. So that's where this method really, really helps you. Again, it's when you have that non-calculator section with something disgusting where you'd have to use the quadratic equation. Make sense? All right. Moving on, number 24. Oh, bless you. The polynomial p to the fourth plus 4p cubed plus blah, 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 blah can be written as p squared minus 1 times p plus 2 squared. Oh, thank God they factored it for us. What are all of the roots of the polynomial? Now, I say that they factored it for us, but this is the SAT. Be very, very suspicious that they probably have only done a halfway job. Okay? Always be suspicious of College Board. So they gave us p squared minus 1 times p plus 2 quantity squared. One of those things I can factor farther. Which one is it? Ma'am? Yeah, this guy. Exponents on the inside are a dead giveaway. I can factor that farther. Exponents on the outside, all that means is that I have 2 of those. I just have p plus 2 times p plus 2. That doesn't give me anywhere. But this one I can break down. How does it break down? What is it? Yes. Right, it's the difference of squares. We covered that last week. So p plus 1 times p minus 1. Square root of p, square root of 1. 1's plus, 1's minus. And then p plus 2 quantity squared. All right. Set that equal to 0 to find your roots. So here, and basically what we're doing is just setting each one equal to 0. So p plus 1 equals 0, p minus 1 equals 0, and p plus 2 equals 0. Solve each one for p. P is negative 1, p is positive 1, and p is negative 2. Those are your 3 roots. And then just look at your answer choices very carefully. And that should be C. All right. Number 9. Mia. For this guy? So what you do here is you set each factor equal to 0. So that means either this part could be equal to 0, this part could be equal to 0, or this part could be equal to 0. And then you solve those individual equations. And that's what winds up flipping the signs on you. No problem. A lot of people don't explain that step, and they don't know why you get reversed. Okay. Number 9 at the bottom. So this is a type of question that is showing up more and more on your SAT. They like to give you 2 equations to solve. One of them will have an exponent, one will not. Okay, so let's read through the question, then talk about how to solve it. The system of equations below is graphed in the xy plane. Which of the following is the y coordinate of the intersection point xy in the graphs of the 2 equations? Now, that's a lot of words that basically means solve for y. That's all it means. Okay, so SAT translation, solve for y. Now, normally, when we had 2 equations and 2 unknowns, all we did was add the equations together or subtract them, and boom, the answer should pop out at us. That works great when they're both linear, when we don't have exponents. When you have exponents, your only choice is substitution. That's all you got. So we have to do substitutions on these types of problems. So, but there's an easy way to substitute and a hard way. So let's look for the easy way. I don't like doing things the hard way. It's inefficient. This is solve for x. I could totally take this and plug it in here for x and in there for x. But that means I'm going to have to FOIL here and I'm going to have to multiply there. There's a lot of room for errors there, guys. Yeah, no. But this top one is solved for y. So I could take this whole thing and just dump it in the bottom one for y. That's one substitution, no FOILing, and no multiplication. So that's what I'm going to do. I'm taking the top one and dumping it in the bottom for y. So x equals x squared minus 6x plus 11, and then I still have this plus 1 hanging out the end. Okay. Before I keep solving, any questions on how I got that? Are we okay? Yeah? Okay, cool. All right, so this is a quadratic, which means push everything to one side, make it equal to 0 and factor. So I'm going to subtract x and then combine my 11 and my 1. So 0 equals x squared minus 7x plus 12. And then factor. So I need, working right to left, I need factors of 12 that add to give me 7, specifically negative 7, but I'll worry about the negative later. So my factors of 12 that add to give me 7 are 3 and 4, and then make them both negative, so you get the negative 7. So negative 3 and negative 4. And again, split those up, set each one equal to 0. So x minus 3 equals 0. X minus 4 equals 0. So x is equal to 3, and x is equal to 4. I have my 2 x's, but my problem asks for y's. So I have to go back to my original equation, which is x equals y plus 1, which I have up there, and just plug it in to get my y's. I could also plug it in the top one, but why do that? That's more work. So if x is equal to 3, 3 equals y plus 1, which would mean that y is equal to 2. So there's one answer. If x is equal to 4, then 4 equals y plus 1, and y will be equal to 3. Those are both correct answers. If this was a grid-in, you could answer either one. Okay, but it's not a grid-in, it's multiple choice, which means only one of them should show up. And only one of them does, it's 2. So that's answer choice C. Any questions? All right, on the next page, those 2 problems are yours for to do for homework. They're very similar to this. In the top one, you're going to find that both of your y's are going to show up in your answers. Okay? But there is something in your problem that tells you which one you have to pick. Ma'am, what's your question?
How did you get to 2?
This one? Yeah. I plugged in 3 for x into this equation right here.
Oh.
Yes, ma'am. Over here? Absolutely. Absolutely. That would definitely be another way to go. You bet. Any other questions? Like I said, this is one that's creeping into your SAT and becoming more and more frequent. So definitely watch out for it. ACT, we haven't seen it yet. All right, last page, imaginary numbers. Everybody's favorite. Nobody likes imaginary numbers, including me. Not my favorite thing. I told my calculus professor I shouldn't have to do imaginary numbers because I quit believing in imaginary things long ago. It didn't fly. All right. So imaginary numbers show up on both tests, your SAT and your ACT. The good news is they are not very frequent problems, so we like that. So as far as what imaginary numbers are, imaginary numbers involve I. I is defined as the square root of -1. Like by definition, that's what it is, okay? But quite honestly, you really don't need to know that. Like we really don't care what it's defined as. It's not going to come up, okay? What you do need to know is a pattern of 4. The powers of I repeat in a pattern of 4. And that pattern of 4 goes like this. I to the first is just I. Kind of makes sense, right? Like x to the first is x. I squared, okay, let's figure out what I squared is. Well, I squared, that means you're taking this guy up here, the root of -1, and squaring him. What happens when you square a square root? They cancel out, right? Somebody's not having a good day. Okay. So those things are going to cancel out. You're just going to be left with -1. So I squared is just -1. I to the third, well, I to the third, that means I have 3 i's. So that means I have I to the first times I to the second. So I have I times -1. So that's -I. I to the fourth, that's 2i squareds. So that's I squared times I squared. It's -1 times -1, that's +1. Okay. This pattern of 4 is going to repeat. I to the fifth will be the same as I to the first. So I to the fifth is the same as this, I to the sixth, I to the seventh, I to the eighth, I to the ninth, and so on and so on and so on and so on. Okay, it's just going to keep going. Bless you. So it's just going to repeat in this pattern of 4 over and over and over. So that's the pattern of 4 you need to know. Now, as far as calculating things with imaginary numbers, the basic concept here is that you're going to treat I like it's any other letter. Okay, so if we're adding complex phrases together, you're going to add your like terms. If we're subtracting, you're going to subtract your like terms. The only difference is going to be in your last step. If you see an I squared, you're going to replace it with -1. If you see an I to the fourth, you're going to replace it with 1. Push that door closed. Okay. Any questions on basic concept? All right, let's do this. ACT number 2. What is the sum of the complex numbers 3 minus 4i and 5 plus 3i? So sum, what operation am I doing? I'm just adding. That's all I'm doing. So I have 3 minus 4i plus 5 plus 3i. Again, all I'm doing here is combining like terms. I'm going to treat I like it's any other letter. So 3 plus 5 is 8. -4i plus 3i, that's like -4x plus 3x. That's -x. It's just -I. Okay, and that's D. That's answer D. And you're done with that problem. These get a very high difficulty rating, but they're not hard. Don't make them difficult. Okay. All right, SAT number 18 below it. In the complex number system, what is the value of the expression blah? Okay, ignore the little note. We don't care. 16 I to the fourth minus 8i squared plus 4. Okay, I don't have anything here to combine. None of my terms are the same, so I'm just on my last step, which is replacing stuff. What's I to the fourth? 1. 16 times 1. What's I squared? -1, because I don't know what negative is in Spanish, plus 4. Okay, so this is 16, -8 times -1 is +8. plus 4, 16 plus 8 plus 4. I believe if I mental math that correctly is 28. So you get in 28. Questions on any of that? Doing okay so far? All right, no freakouts with imaginary numbers, right? We're all good? Okay. All right, last one. In the equation below, a and b are real numbers and I is the root of -1. What is the value of a? All right, so they give us this lovely 15 minus 4i and 6 minus 3i, and they tell us this is equal to a plus bi. All right. Without thinking too much about this, what does your math gut want to do with the right side, the left side of this problem? Factor? FOIL. Okay, which is probably what you meant. The other F word that goes in math. Not the bad F word. Okay, which is also sometimes associated with math. Okay, so first, outer, inner, last. First, and this is without a calculator, which is highly annoying. We got to do 15 times 6. All right, guys, arithmetic shortcut. What's 15 times 2? 30. You got 3 of those because you got to get up to 6. So 90. First, outer, 15 times -3, that's -45i. Inner, -24i. Last, +12i squared. And that's still equal to a plus bi. We haven't done anything on the right. All right, combine some like terms here. We got 90, -69i. Ooh, that was a brain burner right there. Plus 12i squared. I don't know why that was a brain burner, and like 15 times 6 wasn't that hard. But anyway. Okay, so we're down to our last step. We just have to replace I squared and I to the 4th with their appropriate stuff. So what's I squared? -1. Change to -1. Okay. Calculate some more. -90 minus 69i minus 12 equals a plus bi. Combining like terms again. 90 minus 12 is 78. Okay, we're as simplified as we can get. Let's go back to the question. What do they want? What is the value of a? So if I look on the right side, a does not have an I with it. So just match it up to your term on the left that also does not have an I with it. So a must be 78. And then b would be -69. So since they asked me for a, I would give them 78. Okay. Questions? All right. Done with algebra. Well, it'll come back, but we're done with it for right now. All right, so we are going to do, you know what I'm going to do? I'm going to make this easy on myself.